This video, we're going to look at some alternative ways to solve quadratic equations. So, solving quadratic equations. And so, two ways I've already talked about are factoring and zero product principle, and taking square roots. So this next method we call completing the square. And it's tied to this taking square roots. The idea here is, with taking square roots, let's say I have x minus 3 squared equals 7. I can solve that by taking the square root of both sides. You get x minus 3 equals plus or minus the square root of 7. Add 3 to both sides. X equals 3 plus or minus square root of 7. That's how you'd solve that, taking square roots. So with completing the square, it would be that idea, except what happens when things aren't all set up for you to do that. You have something like this, which doesn't factor, but you don't have this expression already here set up, this perfect square trinomial part already set up with the square. How do you fix it so that you can do it that way? And that's where completing the square comes in. So what we're going to do here is, the first thing we're going to do is, and get just quadratic equations here before I get into this, I guess. Quadratic equations, default, they can be written something like this. So a number x squared plus a number x plus a number equals 0, and again, doesn't have to be x, could be whatever variable. So if we're going to complete the square, first step, make your a, this number in front of the x squared, equal 1. Now, in this case, great. In this example I'm looking at, I want to make it a 1. It's already a 1. Awesome, I don't have to do anything. If it was a different number, what I would do is I'd divide everybody by that number, and that's how I'd make it a 1. And we'll do an example where I'll do that. But on this example, it's already 1. I don't have to do anything there. Move the constant to the other side. Alright, so this 2, I'm going to subtract 2 from both sides. And I'm going to get x squared minus 6x equals negative 2. Alright, so move the constant to the other side. The next thing I want to do here is take half of the coefficient of the x term. So this negative 6, I'm going to take half of that, oops, which is negative 3. So take half of that, negative 6, and that's going to give me negative 3. Square this. So I'm going to take negative 3 and square it. Add to both sides. So this is going to become x squared minus 6x plus 9. So I'm adding 9 to that side. And negative 2 plus 9. And now factor the left side, or whatever side this stuff is on. So I'm going to factor these three things, and if I've done this correctly by doing half and squaring and stuff, I should get a perfect square trinomial equal to 7. And now we can see how this side looks like, how this one started, and then solve. So take the square roots of both sides, just like above, x minus 3 equals plus or minus square root of 7, add 3, so x equals 3 plus or minus square root of 7. So that's how you would complete the square on that problem. If you started with something like x squared minus 6x equals 0, and you wanted to do it doing this square root ways, you gotta have to make it a square before you could do the square root. All right, so let's look at a more complicated problem here. So let's say we have 3x squared plus 5x minus 11 equals 0. And I want to solve that. Now, I can try to factor this. I don't think it's going to factor. So now I'm going to complete the square. So I'm going to start off by saying I want this first term to be a 1 and not a 3. So I'm going to divide everybody by 3. And that's going to give me x squared plus 5 thirds x minus 11 thirds equals 0. Then what I'm going to do is I'm going to add this constant, this 11 thirds, to the other side, move it over. So x squared plus 5 thirds x. I'm going to leave myself a blank where I'm going to add in this value here. After I do the whole half and square thing, I'm going to add it in here. And then I'm going to add it in over here as well. So I'm going to take half of this. So if you want to take half of a fraction, you multiply it by a half. And again, top times top, bottom times bottom. So half of 5 thirds is 5/6, positive and squared. So square the top, square the bottom, 25 over 36. So that's what I'm going to add to both sides, 25 over 36. Now, this whole half and square business, what it's doing is it's setting this up so it will factor as x plus 5/6. So when you take half of that middle number, that is actually, and then square it, take half of that middle number, that's actually telling you the number that's going to go inside this factored form. So you might as well just go ahead and write it at the same time and save yourself, a bunch of trouble to come back and pick it up. It's always going to be that. So as long as this is a 1, which is the first step, you need to make it this a 1, then when you take half of that, that's going to be the part in the factored form. So just cleaning up the other side, 11 thirds plus 25/36. That's going to give me 157 over 36. And now my square is complete. I'm going to square root both sides. Square root. X plus 5/6 equals plus or minus. That's 6. Square root of 157. Does that break down? Nope. So square root of 157. And then I'm going to get x by itself. So move that constant to the other side. Plus or minus square root of 157 over 6. Now, this answer is perfectly fine. If you wanted to, since they have a common denominator, it wouldn't be too much trouble to put this as a single fractional statement. That would also work. So either one of these would work as an answer. All right. Now, let's say I completed the square on this most generic version of a quadratic equation. I went through these steps and see what would happen. So I would get rid of this a. A might be 1. I just have no, since this is a very generic, I don't know what these values are. So I'm just going to say, let's just pretend like it's not. And I'm just going to divide everybody by that number, whatever that number is, and that's going to make it a 1x squared. And then that's going to give me these fractions. And then I'm going to move this constant term to the other side. And again, I would subtract that over there. And then become a negative c over a. And then I'm going to put in a term here so that these will factor correctly. So again, if I'm doing this right, then when I take half of b over a, and again, b over a times a half, b over 2a, so that should be what goes in here. And then when you square it, square the top, square the bottom, so b squared over 4a squared. So that's what I got to add over here, 4a squared. And then I want to add these up, and I need a common denominator. That common denominator is going to be 4a squared. So this one needs a 4a to it. And I'm going to switch this order on the top. I'm going to start with b squared, and then minus 4 times a times c. And now I have completed the square. And now I'm going to go ahead and solve this. I'm going to take the square root of both sides. So x plus b over 2a equals plus or minus. Again, square root, just like squaring, do top and bottom. So square root of the top, b squared minus 4ac, square root of the bottom, 2a. And again, you can't separate when you're adding or subtracting under a radical. You can't separate them and do them individually. You got to do it as a group. So I got to keep that together. And then I want to get x by itself. So I'm going to move this b over 2a to the other side, making it negative. So x equals negative b over 2a plus or minus this b squared minus 4ac over 2a. And then since these have a common denominator, I'm just going to go ahead and write this as a single fractional statement. This here is known as the quadratic formula. What it says is that if you have a quadratic equation in this form, then you can use this formula to find the answers always. And if you can identify A, B, and C, then you can plug them into this formula, and this will give you the answers. And those answers don't even have to be real. They can be non-real, and it'll still give you the answers. So I wanted to solve, let's say, 3x squared minus 2x minus 5 equals 0. And, maybe I could factor this, but maybe I'm like, yeah, I really don't like it when there's a number in front of the x squared. I don't do that factoring very well. So I'm going to use this quadratic formula. A equals 3, B equals negative 2, and C equals negative 5. Again, A is the number in front of the x squared term, B is the number in front of the x term, and then C is the constant. It's not necessarily who's first, though it should be if they're put in the correct order of terms, but, A goes with x squared, B goes with x, C is a constant. So I'm going to go to my formula. Negative B plus or minus B squared minus 4AC all over 2A. And I'm going to start filling in my stuff. Negative 2, negative 2 squared minus 4 times 3 times negative 5 all over 2 times 3. And now I'm going to start making this look nicer. So negative 2 is positive 2. 2 times 3 is 6. Plus or minus square root of negative 2 squared, that's a 4. Negative 4 times 3 times negative 5. Negative times negative, that's going to be a positive. 4 times 5 is 20 times 3 is 60. So that's going to be the square root of 64, which is 8. So this is going to be 2 plus or minus 8 over 6. Now the fact that this came out to be a perfect square tells me this was factorable. And then what I'm going to do is I'm going to do 2 plus 8 over 6. So 2 plus 8 is 10 over 6. I'm going to do 2 minus 8, so negative 6 over 6. And then I'm going to reduce these down. So 2 goes in that, so 5/3 is an answer, and negative 1 is an answer. So this was factorable, but that's okay. I still got the answers using the quadratic formula. I didn't have to factor it in order to find those solutions. Now, if you did factor it, you might have been able to get there faster than this formula. So this formula will work for any quadratic. That doesn't necessarily mean it's the best choice. for easier problems, you may want to go ahead and factor it if you can. So let's do one more of these. Let's say I want to solve something along the lines of x squared minus the square root of 5x minus 1. Let's say I want to solve that. So a is 1, b is negative square root of 5, and c is negative 1. And so I'm going to put that in my formula, and so negative b, negative square root, plus or minus 2 times 1, negative square root of 5 squared, that's my b, minus 4 times 1 times negative 1. And I'm going to make this look a little better, so x equals square root of 5, negative, negative, positive 2 plus or minus square root of 5 squared. So negative times negative is going to be a positive. Square root of 5 squared is 5. Negative 4 times 1 times negative 4. Negative times negative. It's going to be positive 4. Square root of 9, which is 3. So this is the square root of 5 plus or minus 3 over 2. And so you can get irrational numbers. If this came out to be a negative, you get i's. Just remember to split your fraction up into 2. And if you kind of go back to the history here that we did, you'll notice that you can, split that quadratic formula up into 2 fractions if you want to. And so if there is an I under that imaginary, from the square root part, giving you a non-real answer, you got an imaginary component, then you would want to do that. You'd want to split it into 2 fractions. So that's solving equations a couple of different ways, completing the square or quadratic formula.